welcome everyone again. This is Women Who Code Python. Our mission is we are a global community, a global nonprofit dedicated to inspire women to excel in their technology careers. Our main goals is to empower with skills for professional achievement, educate companies to better promote and retain and hire talented women, and build a global community where networking and mentorship is valued, develop role models, and support this generation of engineers. Our code of conduct. So we are an inclusive community. Everyone is welcome as long as you support our main goal. So it doesn't matter regardless gender, identity, any orientation. Everyone is welcome to join. We have different tracks. We have front end, we have blockchain, we have Python, which is us. We have mobile, cloud, and data science. We want to thank our sponsors. Without them, we couldn't do this. And this is McKinsey & Company, Python Software Foundation, and the Home Depot. We also have a new sponsor coming in, which is Atlassian. We will be adding them soon, and we're glad to have them coming in with us. So tonight we have PySpark. We're talking about PySpark. ETL made simple with PySpark. This is the part number 1 is gonna be 3 sessions, and the first session is tonight, the second session will be next Wednesday, and the other one next Wednesday. So this is a webinar for Aida, from Aida Martinez. And a little bit about Aida. She's a senior data engineer and software developer with more than 10 years in experience creating data solutions and web applications. She is currently a data integration developer at the company Juice Analytics, where she applies her data engineering skills to build fast and reliable data pipelines using Python, AWS, and Apache Spark. She's a computer science major and holds a master's degree in analytics from Georgia State University, where she was graduated research assistant of the Institute for Insight. In her free time, she can be found practicing yoga, traveling, and learning new cloud and open source technologies. As well, if you think about right now, she's giving her precious time to us tonight to share some good information. So I'm going to stop talking and stop sharing, and I'm gonna welcome Aida to start with her presentation. Thank you, welcome in.
Okay, thank you, Liliana, for the introduction. So happy Wednesday, everybody. I'm going to share, just give me 1 minute. I'm going to share my screen. Can you all see it?
Let us know if you can all see it, please. You can tell us in the chat. Yes, they're saying yes, perfect.
Okay. So we're going to start a series of 3 parts. A little bit about me. So I'm originally from Honduras, and I have been living in Atlanta for the past 5 years. As already Liliana mentioned, I have a computer science major with a master in analytics from Georgia State, and currently working for Juice Analytics as a data integration developer. And I also practice a lot of yoga. I have like 10 years practicing. And you know, sometimes it's really helpful when you have a lot of clients who sends data that it doesn't make sense. So you have to make some time for yourself and your peace of mind. So I would recommend that to all of you as well. You can contact me on my Twitter handle or my email, my personal email, martinezp@gmail.com. So a little bit about where I work. So Juice Analytics is We have our platform called UseBox, what is a modern solution for turning reports and dashboards into interactive data stories. And we are a team of visualization experts trying to change the way the organization discuss and use data. So you can see a couple of examples of the dashboards and reports that we do. Basically, the whole job that I do is to put the data in the right format to basically be read by all these dashboards and reports. And if you want to know a little bit more about Use Analytics, you can go into useanalytics.com. So the agenda for today, we're going to go through some main concepts, and we're going to install and setting up PySpark, and we're going to use Google collaboration for that. So if you don't have a Google account already, then I will tell you to start creating it while I go through some of the main concepts. And we're going to cover as well the data extraction part. On the next sessions, we are going to cover data transformation, data law, and best practices. So a little bit about the Spark history. Spark was a research project that started at US Berkeley AMP lab, and it was open source in early 2010. By 2011, they developed Shark. That was an engine that could run SQL queries over Spark, and they started incorporating Spark streaming as a core component. So by 2013, Spark was transferred to the Apache Software Foundation, and what is called DataFrames were introduced, and we are going to see what they are. By 2014, Spark 1.0 was released. By 2016, we have a 2.0 release. There is a new Spark session that is basically a unified API. And I'm going to go through those concepts in a moment. We also have the structured streaming that basically replace what it was Spark streaming before. So what is a Spark? So a Spark is a distributed data processing engine that supports complex analytics. And what it means to be distributed basically means that you have a collection of many servers all working together like a team, and that they can handle bigger data sets, do analytics, a lot of data crunching, and solve big data problems, because it will spread the whole work across many computers instead of just one. And why do we use Spark? Well, it will run 10 times faster than other solutions like Hadoop, and it will support a wide range of programming languages as Scala, Python, Java, R, and even SQL. So if you already know any of those, it will be easy just to get started on Spark. It also implements a unified platform that it will allow you to combine batch and stream processing using SQL data frames. You can also implement machine learning, do some graph analytics, and Spark streaming as well. It runs everywhere, including Hadoop, Kubernetes, standalone, in the cloud. You can run it locally in your computer, and it can connect to hundreds of data sources. And most importantly, it can scale because of its distributed nature. Some of the use cases using Spark is you can read and process huge files and data sets. You can query, explore data sets. You can process live streams of data, train and evaluate machine learning models, and you can perform analysis on graph data sets and social network. And as you can see, basically Spark has a Spark core right here. And this Spark core is the one that is going to be our point of entry for all of data sources over here. And today we're going to focus on DataFrame API and a little bit on Spark, the Spark SQL module. So those are the ones that we are going to be working on today. And we're going to do some batch processing with them. So let me erase this really quick. So how does it work? Basically, Spark, we have a driver node and we have some worker nodes, and your application, that is all your job, your ETL job specifically, it will be on that driver program. And then we will have a cluster manager, and the cluster manager is the one who is going to take that application and is going to divide it into different tasks and send these tasks to the worker nodes. So the worker nodes, there are processes in charge of running individual tasks in a given Spark job. So that's a really high level. So what is a Spark session? So starting from Apache Spark 2.0, the Spark session became the new entry point for Spark applications. What does this mean? Well, before that, you will have a Hive context for HiveQL API. You will have a streaming context for the streaming API, and you will have SQL context if you want to use that SQL API. So you will have to basically start all these three contexts plus the Spark context to get started into a Spark application. But right now, they just unify all these APIs into what is called a Spark session. So now you only need to basically write your Spark session, define it at the start of your application, and then you will be able to use Hive, streaming, SQL, etc., all of them at once. And there is also a one-to-one correspondence because what it is a Spark session and a Spark application. So the main structure in a Spark is what is called RDDs. So RDDs are resilient distributed data set, and they're the basic building blocks of the Spark applications. And they are fault tolerant, and they can reconstruct the data on failure. They're distributed among all the nodes, and they are collection of partitioned data. So RDDs, they are immutable. What does this mean? Well, it means that you need to create a new variable when you are doing a transformation, because otherwise it won't be saved. And it follows a lazy transformation. And this means that you can write a lot of transformations, but until you call an action, what is called an action, that it can be like a writing to a database or writing to a file, then is when all your code will be executed. So basically Spark, when you are writing all your transformations, will be kind of creating like a graph, and is kind of a query plan like the SQL one. And then at the end, when you call an action, it will execute all of it. So on Spark, transformations are operations that will not be completed at the time that you write them and execute them. They will only get executed once you have called an action. Some of these transformations are select, distinct, group by, sum, average, etc. And actions are commands that are going to be computed by Spark at the time of their execution. And basically they consist of running all the previous transformations in order to get back an actual result. Some of them can be show, count, collect, save, write, etc. And what we're going to focus today is the DataFrame API. And a DataFrame right now is the most common structure. Basically, they are built on top of RDDs. So every time you create a data frame, it will get translated to an RDD on the back. But that will be transparent to you. And a data frame is just like the same as a pandas data frame on an R data frame. It's just a list of columns with the rows. It looks just like a table, and they contain the same characteristics as RDDs, that they are immutable, they are lazy evaluated, and they're distributed. And something that we need to keep in mind is that in the case of PySpark, the performance it gets a little bit lower because basically it has to serialize. PySpark has to serialize all our Python code in the driver to be able to send it to the worker processes. So each time the driver sends all this code to the nodes and vice versa, we get code from the nodes to the driver, it will be serialized. And also on the nodes, there is going to be, the memory will be shared between the Scala, the Java virtual machine and the Python virtual machine. So you will have less performance than when you're writing code in Scala or in Java. And now we're going to go to the notebook. I don't know if I will share probably this into.
Yeah, can you copy that in the chat for us, please?
Yes. So if everyone can go in there, and instead of using this, you will see this notebook over here is in Google Colab. You have a Google account, you can sign in, and then if you go into File, you can save a copy in Drive, and it will save it to your own Google Drive. So just make a copy in your own Drive, and then we're going to start working on it. I already paste the link in there.
Yeah, can everyone see the link? The link is in there. Oh, wait. Let me see. I think it didn't get to everyone. Okay, I'm just sharing it again. Just make sure you tell me that you got it. Okay, now they got it. Perfect.
Okay. So when you open the notebook, then go into File and save a copy in your Drive, and then you can start working on it. So the way this is going to work is I'm going to go through some explanations here, and then you will have time to do some exercises and to test your solutions, okay? So in this workshop, we're going to create an ETL to store crime data from different cities. In this case, we have data from San Francisco, Austin, and Chicago crimes during 2018. And you can see that reference at the end of the notebook for more information about that data sources. So we'll be covering how to install and setting up Spark, and then some data extraction concept like how to read from data sources, how to apply schemas, and how to handle corrupt records. And this basically, Google Collaboration is a notebook that is basically running into a computer in the cloud. So this will pretty much emulate how to install a Spark on your local machine. And you can see over here that you have this gives you around, I don't know, 13 gigs of disk of RAM and 50 of disk. So it's a lot of computer power for you to try out more stuff in here. And you will have also a tab over here on the left where you can see your files, and you can upload, you can refresh, and you can mount from your Google Drive. So basically, in order to run a Spark, you will need to install first the Java JDK over here, and then you can get the latest version of Apache Spark. We already have 2.4, but I'm still using 2.3 because there is still some bugs, especially handling corrupt records. Then you basically will decompress the Spark file over here, and then you will install this Find Spark. You will also need to set up the environment variables. In this case, the Java home and the Spark home. The Java home will have the URL where we installed the Java 8 JDK, and the Spark home will have the folder where it was installed, the Spark over here. So basically, when you are using PySpark, it is not on the sys.path by default. So that's why we use FindSpark to add it to the sys path at runtime. So it's really important. You need to import it, and you need to call findspark.init method before calling PySpark. If you don't do it, then it won't work for you. And for every Spark application, the first operation is to connect to the Spark master and get a Spark session. In this case, we are working like we are in a local machine. So we're going to import a Spark session. You remember a Spark session is the only entry point for the Spark applications starting from Apache Spark 2.0. And we're going to build basically a driver over here, and we are going to tell it local with the asterisk. So this means we are just creating it in a local machine. And this will allow us to interact with DataFrame's APIs and with the SQL module. And you can also go to PySpark SQL module. This is what we are going to be focusing today. And you can see Spark. We have the Spark session over here. We're going to use the data frame, and we're going to see a little bit more afterwards. So in order to get our data, you can use like the normal wget, that is the normal command in Linux to get data sets from the web. So we send the URL over here. This is on S3 bucket in AWS on my account that I made them public, so you can download the data from there. So if you run all these 4 over here, you should be seeing all 4 files appearing over here. And I can show you. See, this one shows. So they all 4 should be here, like Chicago crimes, San Francisco crime, and Austin. So DataFrames is both a data structure and an API. Once created a data frame, it can have methods attached to it, and there are operations that one can perform, such as filtering, counting, aggregating, and many others. And we already discussed that data frames, they are considered immutable storage, and when apply a method to a data frame, its state cannot be modified after it is created. So having that in mind, we're going to start looking into how to read some data. And we have basically Spark has 6 core data sources and hundreds of external data sources written by the community. And you can see over here, each of the 6 core data sources, you have a link to them. And basically these ones will take you to the same documentation that I was showing you before. And you can see all the options that you have for each of them. So you have CSV, you have JSON, Parquet, ORC, database connections, and plain text. Some of the community created data source, their connection to Cassandra, MongoDB, and AWS Redshift. Most of them are done by Databricks, and this is a private company found by the founders of Spark. So they have been continue doing some work on their side. So basically for all connections to data sources, they follow the same pattern. You can do a spark.read.options and then apply a key value options over here, and you can define a connection type. And the endpoint will be the path to your file. This connection type in this case can be a CSV, JDBC, Parquet, JSON, etc. So when you are reading over here into Spark data frame, the cluster manager, it will basically send all this data and distribute it into the workers. So it will divide all your file in several parts, or what they call tasks, and they will send it to each of the nodes. It will assign what is called a memory partition. Okay. So in this case, you will find out that there are different ways to do the same thing. So we can read data by using options over this, the option like header equal true, or infer schema true, and you can use dot connection type. Or for example, you can use the data frame reader dot format, followed by option, dot schema, and low. So that is another way, and you can see it over here. It's another way that you can use to read data. So it doesn't matter which one you should choose, or my advice is to choose the one you feel more comfortable with. And in this case, on the format, it would be CSV, would be JSON, would be any of the data sources that we have before. So in this case, infer schema is telling Spark that it infers all the columns and their data types. And then on the low, you will send the name of your file. In this case, my path, how it's locally, it will be on the same folder as my notebook. And you can see that we use, for example, show to see the first lines in a data frame. In this case, we're going to see only the first 5 rows in our San Francisco data frame. There is another option to read over here. And if you can see, instead of doing a low of my path, I can also send it as an option. And I can put the path and then the name of my file or the path where it is. You can also put in here, for example, if you already have your file on an S3 bucket, you can define here your path, like S3 dot / and the name of your bucket and the whole path. And then you can call .low over here. So you already saw 3 different ways that you can read a file, and just follow the one that you feel more comfortable with. And if you can see here, all this code is enclosed in parentheses. If you don't enclose all the code in parentheses, then you will have to define like a slash over here on each of the rows, which I'm pretty lazy and I don't like to do. So my advice is the easiest way, just to get this well format working, is just to enclose it on parentheses instead of defining the slash or backslash in each of the lines. And we can see we get basically the same data in each of these reads. So it doesn't matter how do you do it. You can use any of those options. So I will give you a couple of minutes to try and read the Austin crime data and the Chicago one, and then I will give you the solution. Let me know if you have any questions so far.
Yeah, if you have any questions, you can write them out, or you can also, I think you have an option, but if you want to talk, I believe I can give you access to talk. Someone was asking me in the Q&A questions that they got an error with the first line, so I just send you a message just to make sure you copy the notebook in your drive, because if you don't copy it, it's not gonna work for you. So I just wanted to make sure you copy it into your drive. If you have any other questions, you can write them in as well. I think you also have an option like to raise your hand, so I could give you the way to talk as well if you want to. So someone is asking there, how are the number of working nodes decided?
So that depends in a lot of factors. First, it depends, for example, if you are reading a lot of small files from the same path, then it will basically create a partition for each of those files. And then when you are defining your cluster, basically you define how many worker nodes you want, how many partitions. So, so for example, in AWS, that is where I usually work, I will define how many executors I want to have. But that will depend how much data you have. Usually you should have around files of around 200 megabytes per partition. And each partition, it will be one-to-one with an executor.
Perfect, thank you. And we also have another question here. How is Spark different from Hadoop? Hadoop, did I say that right?
So yeah, Hadoop. So I think the main difference is that on Hadoop, you have to, everything is written to disk. So all the transformations and operations are done at the disk level. On a Spark, you are doing everything on memory. So that's what it makes it so fast, because it's working on memory. And in the case of Hadoop, you will also have like the MapReduce. So at least on my case, I think Spark is so much easier to learn. And you will basically use structures like the data frames that are pretty similar to the data frames in Pandas and in R. So it has support for other languages like Python, R, Scala, Java, etc. So I think that makes it a little bit more open to more people than Hadoop, where Hadoop you will have to learn like the specific syntaxes of it.
Awesome, thank you.
So is everybody able to read the Austin crime data and the Chicago one?
Let us know if you have any questions about it. I was able, yay, I never done this actually. So is everyone able? No, I don't know that much about PySpark. Is everyone able to do it? Anyone has a question or needs some help? Hey, Wonder Woman, are you there? I think you can talk now in case you have a question. I was trying to test this unmute thing because it's a little weird.
Can you hear me now?
Yes.
Yeah, it was good. I ran it.
Awesome. Perfect. Anyone else, any issues? So she can move forward then?
No more issues.
I love this. Thanks so much for having this workshop.
You're welcome. Okay, let's continue then. Where are we? Let me see. Okay, so you already read your Austin crime data, hopefully, and you test passed. And then we have the Chicago crimes, and it should be passing as well. So you can also add a lot more of options, like for instance, option for reading CSV data. They can include whether you have a header or not. You can define your delimiter. By default is comma, but if you have a semicolon or a pipe, then you can define it as an option. And you can also call the infer schema as well. That this option is by default true. So it doesn't matter if you put it there or not, it will always infer the schema. So Spark doesn't read the header by default. So you will need to specify header equal to true option every time you have a file with a header. So that's really important here. And you have the links over here to the CSV, JDBC, and JSON. You can see all the options over there. I think you can define, for example, your dates formats of datetime formats when you are reading, and other options that are really helpful. So some other methods that are really helpful are the ones for collecting rows. Some of them we have take, that it would take the first 5 rows over here, and the show method that it will print by default in a really nice format over here, the first 20 records. And you can see my data frame over here is defined with rows. So row is an object over here. So your data frame, it contains rows. Other thing is, you can see here when I call the method show without any parameters, that it doesn't show the whole column over here, the whole value. But if you call it with the second parameter as false, then you will have the whole value showing up for you. And there is also this method called collect. And I can tell you from now, when you have a really big data set, this is a really bad practice to call collect. So you don't call collect when you have really big data sets, because what collect does is basically it tells to my driver to call all the data that is on the nodes. So that means all the data that is distributed in the different nodes will basically get back to my driver. And that means it will take a long time. And then if you are doing another transformation afterwards, that means it will send over again all this data to the nodes. So it's a really bad practice to do it. So now I will give you another couple of minutes just to try out some of them over here. And then let me know if you have any questions. Okay, so if nobody has questions, we're going to start moving on. So you can see over here, if you want to get the first 5 rows, we show you want to collect all the data frame, you use collect. And if you want to select only the first 2 rows, you can use take. Well, take or show, it doesn't matter. We also have other data frame methods. Some of them is count, that it will return you the number of columns in the data frame. Columns, it will give you the column names. The types, it will return their data types. And describe, that basically works a lot like Pandas data frame. It will give you all the stats for the numeric string columns. We also have limit that will limit the result count. It works pretty similar to the SQL limit. So you will see with data frames a lot of similarities with the Pandas data frame and also with SQL. So when they created data frames, they basically have in mind that they have to be as close as possible to the data frames that people already knew in Python and in R. And that it also has to be similar, or it would be easy to use SQL using their API. So you will see a lot of similarities there. So you can do the next exercise as well using some of these methods and see how it goes. I will give you a minute to do that. Okay, any questions so far? Are we good?
So Kunal just sent an error. Like I think, did you whenever you created your Austin crimes, did you name it like that? Because it might be that you even didn't run it, your data frame, or maybe you didn't name it that way. So make sure you name it like that and you run it again. Does anyone has any questions about the ones that we have right now? Record count.
So you should get something like this when you're running columns with all your column names. And if you use the dtypes method, you should get each of your, like a dictionary with each of your columns with the type over here. Everything okay so far then?
Test pass, yes, seems like everything is okay.
Okay. So one important thing when you are reading data into your data frame is to define an schema. So if you have you have a really big data set, you really need to think about performance. And for example, in the beginning, when we were reading data, we were basically, Spark was trying to infer the schema for us. But this requires two things. One, the Spark will read once all the data set just to find out what is the structure, what are the column names and the type of them. And then it will do a second pass just to read the data. So this is not really good on performance, especially when you are reading a really big data frame, about millions or petabytes of data. So in this case, one of the solutions is that you define your schema and you give it to a Spark when it's reading data. And you can, for example, is if you have like a small table with 30 columns, maybe it's not worth it to do all this work. But if you have a really big data frame with like 10 or 20 columns, then it is worth that you start creating your own schema and pass it to a Spark when reading data. So we will see some steps on how to do this. So first of all, you can use the print schema to have an idea of what columns do you have and the type of them, and if they are nullable or not. And in order to start like building the schema for your data frame, the first step, or what I would do, is to define the schema. Use this method called schema, and then print it out. And once you have it printed out over here, you can see that it has all this, like a structure over here. It starts with a struct type, and then it will define each of the fields with a struct field. And you can do this exercise right now if you want to. It should be really, really quick. I will give you just like 1 minute to do it, and then we're going to move on. And just take a look and try to see which fields are common between all the data frames and which seem to be totally different. So you should be getting these results over here. And then you need to assign the schema to a variable over here. And do the same for the Chicago crimes data. And everybody doing fine so far?
Doing great. Thank you.
Okay, cool. So in order to define your schema, first, you need to use PySpark SQL types, and then you need to import only the types you are going to need. At this time, we don't know which types we are going to need, so probably this is the last part that you are going to do. Then when defining your schema over here, so for example, what I usually do is I will print my schema, like over here, and then I will basically copy all this schema over here. So I will do a copy of all of it, and I will paste it over here, and I will assign it to a variable. So this structure needs a little bit of changes, but it will be a lot faster than defining it by hand. So for example, instead of this list over here, you will need to replace it by a square bracket. And then each of the columns, you will need to put it inside double quotes, like this one. For example, with the types, for example, here is a integer type, you will need to add the parentheses, like this one over here. And the last parameter true, you will need to change it with uppercase T or with F, uppercase F in the case of false. So, and then at the end, I think at the end, instead of having 3 parentheses like this, you have to replace the middle one by the closing square bracket. So usually this is what I do when I want to define a schema, because sometimes you can have like a 20, 30 columns, and it will take you a lot of time to define those. So that's the easiest way. And we can see here, so how you can define, and then you will look at your types. Well, the first one you need to define is a struct type and a struct field. These are going to be there always. And then you need to see the types that you have defined over here and just add them on the import statement. So it's really a good practice just to import the ones that you need. And then if we go down, you can see that we can read now our data frame using the schema method that is here. And on the schema method, we send our schema variable. That is the one that we just defined over here. So this will improve a lot the performance when reading your data frame, because Spark will do only one pass, and that pass will be to read the data. And then you can also see again your data frame over here and make sure that you're getting the same results as reading with the infer schema option that we had before. So the benefits of using a defined schema include avoiding that extra scan of your data, providing alternative data types. So for example, if you have an integer and you want to change it to a float, then you can define, instead of the integer type, you can define a float type and read it as a float. Or for example, sometimes when you're doing the infer schema, Spark will read your dates as a string. So when you are defining your schema, you can tell Spark to read it as a date type, and Spark will do it. And in the case of JSON files, defining a schema will help you to read only the fields that you need. So for example, you have a nested JSON and you have a lot of keys over there. You only need to define in your schema the ones you want, and those are the ones that Spark is going to read into the data frame. So you don't need to import all of it. So now, if you want to take around 5 minutes to define the Chicago crime data frame, data schema, and give it a try and see how it goes.
Let us know if you encountered any questions or something, or anything that you want to add or say in the meantime. So I have a question myself. Would you always prefer to use the defined schema? Would you always use it?
It depends. So if you have a really big data frame, so data sets, it is better to use it. But as I said before, if you have a really small table and you have like 30 columns, for me, it's not worth that time to be defining all of them and the whole structure. So I will leave it just as infer schema instead.
Perfect, thank you. So Kunal says that he has to leave, but he's running late for something. And thank you and great workshop, and hope to continue over the next week with your happy Wednesday greetings, and really appreciate your effort for as well the scripted collab. Thank you.
Thank you, Kunal. Have a good evening.
So Crystal says, yay, it passed the last test. I got to the drop malform one.
Yay, Crystal. Good job. Okay, is people still working on the schema one?
It seems like.
Okay, so you're defining your Chicago schema. It would look like something like this. And you should be able to read it using this schema with a header equal to true and with format CSV. And you will be able to see your data over here. You call the show method. If it doesn't show, if it shows all null, then you have some problems with your structure on the schema. For CSVs, it's really important that you define each of the columns. If you, for example, delete one of them, then it won't work. The only time when you can define only the ones that you want to read is when reading JSON files. For CSV, you need to define all the columns. So that's really important that you keep that in mind. So next move to the last section, that is handling corrupt records. And as you know, when you are building ETL pipelines, you need to have a robust solutions. And Spark give you some tools to check into your data and to see whether it has some missing information or is incomplete, or for example, it have different formats of data types, or it is in general a malformed data. Some of the read modes that we have for it, There are three. One is called permissive, and this one basically will set all the fields to null where it encounters a corrupt record. So this is done by row. So if a row is malformed, then it will set all these fields to null. And then we will have an extra column called corrupt record, where it will have the value of the whole line that is coming from the source dataset. Then we have drop malform, and drop malform basically will drop the row that contains the malformed records. And will have fail fast. They will fail immediately when it encounters a malformed record. So it will depend on each case, whatever you want to do, or if you need your ETL, for example, if you need to know immediately that is something wrong, then you would use fail fast. If you want to do, for example, something with your corrupt records, you can use permissive, and then you can extract that malformed records, and you can send it over, for example, to another folder or to S3, and you can do, you can, for example, try to fix them, or if you already know what the problem is, you want to automate that. Other times you don't really care that from a million records, there are 2 or 3 malformed, so you don't care to drop them, so you can use drop malform on that cases. But it will depend on your specific case. And for Spark, the default will be always permissive. So on the permissive mode, for example, remember that I told you that for CSV, you need to define all your columns in the schema. So then if I commented out one of them, this should fail. So you will see that when I read it, I define an option called mode that will be permissive. And permissive is the default one. So you don't really need to define it in here. You can put it, but it doesn't matter. And other important part is on the schema over here. At the end, you need to define the corrupt record as a string type. So this column is the one that will contain your malformed record. And we will see it over here. If you run this, you can see all these fields are null. And at the end, you will have a corrupt record. And it will show you the value over here. Okay? So that's the case when I just commented out one of the columns. There are other cases where I can have a file, for example, when some records have less or more fields. So when it meets a record having fewer tokens than the length of the schema, it will set to null the extra fields. When it has more tokens than the length of the schema, it will drop these extra records. These extra fields, sorry. And in both cases, the corrupt record will contain the string value of the whole row. So you already imported at the beginning of the workshop this file called San Francisco Crime 2018 corrupt. So basically this file contains one record that has more fields and one that has less fields. And you can see on my schema, I define the corrupt record column, and you need to define it with this specific name. Otherwise, it won't work. So if I read it over here as a CSV, and I define my mode permissive, again, you don't need to define it because this is the default one. And you load the corrupt file over here. Then I can see, for example, I can filter out only the ones where corrupt record is not null. So that means there is something wrong with it. And in this case, we can see there are two rows over here. The first one, so the first one basically was missing these two fields at the end. You can see that we don't have, so these fields over here are being missed on the first row. And on the second one, I'm putting this testing is an extra field. So you can see over here, the testing one, it just get dropped. And on the first one, the longitude and the point that were the ones missing, it will just assign a null to them. So this is the behavior that you can expect when using a permissive mode. And this is the same one, so you can see that with less columns, it will assign just null over here. And with the extra column, it will just drop that testing. So the next one will be fail fast, and this will fail immediately, that it encounter a corrupt record. And in this case, it will use the same data set, the corrupt San Francisco crime data set, and we change the mode to fail fast. Then you will have over here an error. And you can see that it says aborted, and then over here will tell you malformed CSV record. So this one will be failed immediately, and there is nothing that you can do there. And finally, the drop malform mode. This one, it will just drop them. It will drop the ones. So we can compare, for example, if we read again the one with permissive mode over here, you can see, let me see, on this one, you can see that we have 532 over here in the count. And now I will give you some minutes so you can do this drop malform, implemented it on the San Francisco crime, and you will be able to compare. So you should have at the end 2 less records, so you will need to have 530 instead. So I give you a couple of minutes to work on that. Let me know if you have any questions.
So everybody doing okay? Okay, good. Let me know if you have questions. I think we are going to wrap up soon. This is the last exercise. So if you were able to read it with the option drop-down form, then you will see that you will have 2 less records over here because they were dropped. So your test should be able to pass. So let's wrap up this session and let me know, do you have any more questions right now or
Yes, anyone has any questions, and we will continue next Wednesday.
No, you're welcome, Kristen. And let me know if you need more information about really specific stuff. I can get more resources to you as well.
This was very helpful, great workshop, more reading to do.
Good, I'm glad you really like it.
So if we don't have any more questions for tonight, we're gonna close. Just remember, if you know anyone else who is interested on this, they can join next week as well. So we are recording this and we can share it later as well. So they can go, you can guys go through it as well if you wanna do it too. And just remember that next Wednesday is gonna be about the same time. So if no one else has any other questions, we're gonna close. And thank you, Aida, for all your time and all this help during this session tonight. And we'll meet again next Wednesday.
Yeah, sure. Good job, guys. Have a great evening.
Thank you, you too.